Okay, boys and girls, this is Mrs. Mouton, and this is the last video. This is subtracting using unlike fractions, and we're going to do it a little different this time because this time both of the denominators are will have to be changed. So remember, we're looking for like denominators. You cannot subtract unless you have like denominators. So we write the first fraction, which is 2/4. Let me change that color. That's awful, even though it's Valentine's Day. 2/4 is the first fraction. We have to model it. There are 4 equal parts, so 1, 2, 3, 4. And for right now, we are focusing on 2. So I'm going to shade in 2 of the 4 parts. And then I write the next fraction, which is 2/6. And by the way, it does matter what direction we write these fractions in because it's asking us for the difference, which means we're going to subtract, and they'll give you the larger fraction first. So you have to be careful that you write that 2/4 first before the 2/6. Then model it. This time there are 6 equal parts. 1, 2, 3, 4, 5, 6. And again, 2 of them need to be shaded. 1, 2. We cannot write the numerator here because they don't have the same denominator, and we can clearly see they do not match up. So for the one that is shorter, we want to put another model of 2/4. Remember, we want the two fraction models or logs to match up. That will tell us that they have the same denominator when they have the same number of equal parts. So we put another 2/4. 1, 2, 3, 4 equal parts. And 1, 2 of them are shaded, but it's still not matching here, so I have to try another 2/6. 1, 2, 3, 4, 5, 6. And 2 of them are shaded. Again, we have this part up here. It's still not matching, so we have to put yet another model, another 2/4. 1, 2, 3, 4 equal parts. And 1, 2 are shaded. And now we have 2 logs that are the same length, which means they have the same denominator. That was our whole objective, is to get them to have the same denominator because we cannot add or subtract without the same denominator. How many parts do they now have? Well, this is no longer 2/4. This first section here was 2/4, but now we added another 2/4 and another 2/4. And this is no longer 2/6. This was 2/6, but we added another 2/6. So we have to find out what new fractions we have. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We now have 12 equal parts. That's our new denominator. And to find out our new numerator, let's get rid of these so we can't see them. Our new numerator, we count the shaded parts. 1, 2, 3, 4, 5, 6. So we now have 6/12 has replaced the 2/4. And we'll figure out which fraction replaced the 2/6. We know it's 12 equal parts because we know that our logs line up. So our denominator again is going to be 12. We can count them if we like, but we know they're 12 because now they have what we call common or like denominators. Then we count the shaded parts. 1, 2, 3, 4. There are 4 shaded parts out of the 12. And now it told us up here that we're finding the difference, so we need to subtract. Because our denominators are the same, we could just simply write them and subtract them. 6/12 minus 4/12. 6 minus 4 is 2. And then 12ths. And later on we'll learn how to reduce this to simplest form, which would actually be 1/6 because we could divide each of them by 6 by 2, I'm sorry, and get 1/6 as our lowest terms. But we're not going to deal with that right now. We will later on this week and into next week learn how to do that. We can also do it using the models or the log. So we're taking away 4/12 from our 6/12. So all we have to do is make sure we do the same on the top as we do on the bottom. Take away 1, that's counted as 1, 2, because they won't always match up this time, 3, 4, and then see how many we have left. We can draw our log for our answer, and then you just shade the parts that are left over. 1, 2. These are the 2 parts right here that were left over. And then count them. 1, 2, out of how many? 12. 2/12 is our answer. And this particular method really helps students when they end up with an improper fraction when they're adding. So if the numerator is larger than the denominator, they would know that they would just fill in a row and then make a new model for whatever they had left. So seeing it visually seems to help them, and it also helps in the case of when they get an improper fraction for an answer, which we will be going into later on this week, and I'll try to post another video with that information.